So what is the dimensionless number? This is very important in this convection term because as I said, there are the number of variables and all the variables we try to make together and make one number, and that number we call it is a dimensionless number. Now when you are doing an experiment and try to get the values, it may be very difficult for you to just note down the various variables and then finding which variables may be affect, which variables is not affect. Okay, so what we do, we are doing a easy thing that we have a one dimensionless number. We make the variables in a group, and on that basis we give the judgment what happened to the rate of heat transfer, what happened to the that condition when a certain conditions are changed, and that they are make the variables together, that we call it is a dimensionless number. Now here it is given, in order to reduce the number of total variables, combine the variables into the dimensionless number. It's simple. To reducing the number of total variables, what we do, we are making a dimensionless number. Now first we see what is the Nusselt number. This is very important, Nusselt number, when you are dealing with the convection heat transfer coefficient. So there is the four numbers always we are taking. The one is the Nusselt number. You just remember, even you remember the ratio of it, you remember the variables in it of number, that is Nusselt number, Reynolds number, one is the Prandtl number, and one is the Grashof number. At least this four is very important. Even many times even in a gate examination they are asking the number of numbers, dimensionless number, in the heat transfer as well as in the mass transfer. What is the analogy of the dimensionless number in the heat and mass? When they ask the questions related to that, so it is very important to know the dimensionless numbers in the heat transfer as well as in even in the mass transfer. So first we look out the Nusselt number. Now what do you mean by Nusselt number? Now if you see the equation for the Nusselt number, it is H, L, C and K. Now if you see this one, even this formula is again related to the Bharat number that we learn in the answer district process. A Bharat number is H, characteristic length and the conductivity, right? But there is, we could take the conductivity of the body. Fine. Now here this K is the conductivity of the fluid. Okay, so Nusselt number and Bharat number have the same formula, only the difference we are taking the thermal conductivity of the fluid here. So what is H? H is the heat transfer coefficient. L, C, the characteristic length, and the K, don't confuse here the K. When you dealing with the convection one, always the K is the heat transfer, the thermal conductivity of the fluid. So it is given thermal conductivity of the fluid. Fine. So this is the Nusselt number. Now, is it a way that any randomly you are choosing the variable and just make the number? Then answer is no. There are the certain rules, certain assumptions, and on that assumptions they are making these numbers. But not just directly say that there are certain number of variables and we just collect the 10 numbers and we divide it into the 3, 3, 3 and 1, or 3, 3, 3 and 4, or 3, 3, 4. It means we are not doing that part. So there is certain logic, there are certain assumptions, and on the basis of the assumptions we are making, they made the numbers. So Nusselt, they found the number, that's why it give the Nusselt number. Even you can search the name of the scientist which derived this Nusselt number, give the name, it is called a Nusselt number. Okay, so see how the Nusselt number is derived. So look at how the Nusselt equation is found. So see, this is the picture. So there are the 2 point. At one point the temperature is T2, at the another side the temperature is T1, and the fluid layers are there. Then heat is transferred from the T2 to T1, from the surface to the fluid. Now L is the length of the 2 plates. So we here take The heat transfer through the layer will be convection when the fluid involves some motion, and by conduction when the fluid layer is motionless. So what we learn in the first slide, where we call there is a the heat transfer by the convection when the fluid is in motion, fluid is in motion, okay, and when the fluid is in a steady or it is motionless, then the conduction takes place. So the same funda is here. So it is the consider the two parallel plates having a different temperatures. The T2 is a higher temperature, T1 is lower. That's why the heat is transferred from plate 1 to plate 2, as I shown you in the last slide. Okay, and the distance between these two plates is L, and heat is transferred from this plate to the air. So what is the condition? The one case when the convection takes place, the heat transfer by convection, we have the formula HA delta T. And when the conduction, when the fluid is in motionless, then the conduction. So what is the formula for conduction? It is K A delta T by L. Now when we are taking the ratio of these two, it will give the Nusselt number. So taking the ratios, so what we are dividing this part. So just by dividing the Q convection by Q conduction, and we have these two equations that we know very well, and then we found the equation that is Q convection by Q conduction. Then we will get it is H L by K. A is the common, that can get cancelled, delta T is cancelled, and the remaining equation is H L by K, where H is the heat transfer coefficient, L is the characteristic length, and K is the conductivity of the fluid. Okay, so by this way the Nusselt number is formed.